So this video is going to take you guys through all the different types of problems we can do in Chapter 3 with our normal curves, where they fall on exact numbers that we know, and when you have to actually use the table. So if you're struggling with any of these exercises or the problem set, take 10 minutes, watch this one, and try and match them up and do similar things with them. So I just came up with some scenario. So let's pretend I gave some intelligence tests. The scores are normally distributed. So when you see that normally distributed, you know it's the perfect bell curve. Okay, you know most people right in the middle, kind of extremes out on each end. So I tell you an average. So the book uses both X bar and the Greek U for average. So the average is 150 points. And then I give you a deviation. So that's the little sideways O with a tail of 6 points. So I'm going to ask you 5 different questions off of this. Okay, we're going to take these one at a time. So first question, find the percentage of scores that fall from 138 to 156. Now the trick with this one is these numbers are multiples of 6 as far as subtracting from the 150. So this is one where you can draw your curve right in the middle. You can put your average, so your X bar. So this is 150. And then we're always going to go 3 deviations in each direction. So we're going to add, this is plus 1 deviation here. So we're going to add it to get to 156. This is plus 2 deviations. So we add 6 again to get to a 162. And we add 3 deviations to get to a 168. Now we come back 3 deviations. So this is minus 1, 144. This is minus 2, gets us to 138, and minus 3 gets us to 132. Okay? Now, if something's normally distributed, we have set percentages that fall. So this is 34%, this is the 13.5%, and this is the 2.5%, and it's the same thing coming back this way. So again, 68% of the data falls within 1 deviation. 95% of the data falls within 2 deviations, and 100% of the data falls within all 3. So if we want to answer this question, I want to go from 138 up through 156 points. So what percent of kids fell from here to here? So we're just going to take these percentages and just add them up. So I'm going to take 13.5. I'm going to take 34. I'm going to take another 34. And this is going to give me 68, and 13.5 is 81.5%. Okay? So it's not saying 81 kids scored from 138 to 156. It's saying 81.5% of the total kids scored from there to there. Okay, there's the first problem. Here's the second one. If 250 students took the exam, find the number of them scoring higher than a 162. So for this one, I'm actually going to go back to this picture here and use the same curve. So, just going to use the snipping tool and steal this picture, paste it over here, because the curve's still going to work. So now I want to know how many kids scored higher than a 162. So what I care about is from 162 on. That corresponds to 2.5%. So 2.5% of the 250 kids. So it's just a coincidence that I came up with that number. So 2.5%, make sure you move the decimal 2 places. Grab your calculator. 250 times 0.025. Okay, so 6.25 kids. So it's not going to be exact. So we're going to say about 6 kids. And now I could really ask any types of problems off of these. I could have you go from, here to here. I could have you go less than 156. I could have you go here to here and also here to here. Okay, you're just adding percentages that fall in those ranges. Next question. So what if I ask the percentage of kids who scored less than a 146? So if we paste that picture on there again, here's our curve. What we notice, 146 is going to be about right here. So we want what percent of kids scored less than this. So we want all of this. So we know we have the 2.5, we know we have the 13.5, but how do we know how to split up this 34% there? So that's where this isn't going to help us out anymore. So what we have to do is we have a formula where we can find a z-score. Okay, z-scores correspond to these right here. So this is 1 z-score, 2 z-score, 3 z-score, -1, -2, -3. So we're going to use this formula and then also that table A, so make sure you have your book with you. So I want to know what percent of kids scored less than a 146. Okay, if I think about this formula, I have the average, I have the deviation, score of 146 is going to go right here with the x. So first thing I'm going to do, find a z-score. 146 minus my average, all over my deviation of 6. So this is -4/6. We said it should be about right here. So anything below the average is a negative z-score. So you go to your calculator, you say -4 divided by 6. Okay, -0.66 repeating. So we'll just call it this. Now, you got to go to your table and find the z-score that corresponds to this. So we go to table A. We're looking for -0.6. So we follow this over till we get to the column with the 6 in it. And there we go. 0.2546. Now that's always coming from the left. So we go back to our picture. What was that number? 0.2546, so 25.5%. So this z-score here corresponds to 25.5% to the left. So the question asked us, what percent of students scored less than a 146? So we color this in. Okay, this looks like it could be 25.5%, so we say that's going to be our correct answer. Now, if I change the question to what percent of students scored more than a 146, we would want everything this way. We would do the problem exactly the same, but the table's still going to tell us 25.5%, but that's always going to be this part, so we would just subtract from 100%. Okay, so that's why you draw a picture so your answer always makes sense. Okay, next problem. What percent of students scored between a 137 and a 159? So again, if you go back to the curve, those numbers are not down here. So those set percentages will not help us. So what we have to do is we got to find a z-score for this. We got to find a z-score for this. We have to do this formula twice. So 137 minus the average over 6. And then also 159 minus the average over 6. So I'm going to pause it here and do some calculation. Okay, so I've found my two z-scores. One's positive, one's negative, and I also drew a little picture up here. So it doesn't have to be perfectly to scale, just approximate. So I threw the average in, 137 is less, 159 is more. So I'm looking for this area in here. Okay, so that'll help us confirm that this z-score should be negative, it's below average. this z-score should be positive, it's above average. So now we go to the table and we find these two z-scores. So negative 2.16. So negative 2.1, come over here to the 6. All right, so that's 1.5% of the data is to the left of that. So I'm going to come back to the picture here, and this corresponds to 1.5% of the data is to the left of that. Now I'm going to go back to the table. I got to find 1.5. So I need to go to the positive one. 1.50 is this one right here. So 93.3%. So this corresponds to 93.3%. So now I have my two percentages for here and here. So I simply just want to subtract these. I'm trying to find the amount of percent in between these. So I'm going to take 93.3. I'm going to subtract a 1.5, and I'm going to get 91.8%. So 92% of the kids scored between here and here. Okay, next problem. Find the score at which the top 10% of the students had a score of. So you know what score puts you in the top 10%. So if you draw a curve, the top 10% is this right here. So if you go to the table and you look at 10%, that's going to give you something down here for 10%. The top 10% means you have to look for the 90th percentile, okay? Because it's always coming from the left. So there's going to be 90% of the data back this way. So this is, you're given a percent, you have to find a z-score. So we come here, okay, we try and find the closest thing we can to 90%, because 10% won't give us a curve that looks like this here. Okay, so we go to the table. 90%. Both of these are really close. This one's a little bit closer, so that corresponds to a 1.28. Okay, so we come back to our picture and we say this right here has a z-score of 1.28. So now when you think about your formula, x minus average over deviation. You just found a z-score. We have the deviation, we have the average. This is the only thing we don't know. So we go plug everything in. 1.28 x minus average of 150 all over deviation of 6. Now we simply solve this. Okay, the way we're going to solve this, multiply by 6, multiply by 6. These will cancel. So we take a calculator. 6 times a 1.28. Okay, 7.68. This equals x minus 150. So we add this. We just simply add a 150 to get rid of it, and we get 157.68. So once you get here, it's just a simple little one-step equation. So any kid that scored more than a 157.6, so basically any kid scored more than a 158 would be in the top 10%. So there in 14 minutes, we were able to get through pretty much all the problems you're going to have to do in Chapter 9. In also doing that lesson, we hit on one of the high school math standards. So this is Standard 3. It's a whole standard on data analysis, statistics, and probability. Within there, we looked at this one here, using the mean and standard deviation to fit it to a normal distribution and estimate population percentages and identify data sets for which such a procedure is not appropriate. So we hit in the standard of summarizing, representing, and interpreting data on a single count or measurement variable. So all I told you was what the average test score was and what the standard deviation was. And you were able, and that it was normally distributed, you were able to create the curve and answer those questions. So, I could have you come up with 10 other questions just like this, and the process is going to be the same for all of these. And so the things we are doing in class do hit on standards that every high school student is expected to have.